Here we are at example 3 from our 1.4 number 2 set of notes. We're asked to determine where this function f of x is equal to the square root of 4 minus x squared is in fact continuous. Now before we really dive into things, let's go ahead and just draw a rough sketch of what this thing would look like. At the x value 0, when you throw that in there, you end up with just the square root of 4, which just comes out to be 2. If you were to throw in the value 2 in for x, you'd end up with 4 minus, really this would be 4 when you plug that in. So that'll just come out to be the square root of 0, and the square root of 0 is just 0. Likewise, if you plug in negative 2, you'd end up with negative 2 squared. Well, that's positive 4. So ultimately you have 4 minus 4, which again is just 0 underneath your square root. So that'll just come out to be 0 as well. So we would see kind of this arc-like image. You could also throw that in your calculator and verify for yourself. Now, the reason why this is going from negative 2 to positive 2, just between this interval, has to deal with a little bit from our Algebra 2 notes. Anytime you have like this square root like this, we know that whatever is underneath here has to be larger than or equal to 0. If it's less than 0, you start ending up with these imaginary items. And unfortunately, we can't graph that in a real XY coordinate plane. And as a result, things have to be larger than or equal to 0 inside of here. It can be 0, that's why we have this little bar underneath, but, and again, that's illustrated right here and here, but it at least has to be larger than or equal to 0. And as a result, for our x's, we see that they are ranging from negative 2 to positive 2. Now, let's go ahead and test the endpoints to see if, in fact, it is continuous right here and here. I mean, from our graph, we can see that they are, but let's go ahead and actually verify using our 3-step criteria. So we're going to test our endpoints to see if those are in fact included as well. So we're going to test the endpoints. We'll do 2 over here. So we're looking specifically at this value. Is that value 2 included in this interval? Well, for our first criteria, does the function exist at 2? In other words, when you throw in 2 into the function, does it exist? Well, yes, it does. We see that it's very clearly coming up with a y value 0. So this does exist. Part 2 says the limit as x approaches 2. Now we are actually approaching 2 from just the left. Notice there's nothing to the right of this function, so that's why we're just going to check it from the left of our square root of 4 minus x squared. Well, if you were to use direct evaluation here, it does in fact come out to be 0. Step 3 simply says that the limit as x approaches 2 from the left of our function 4 minus x squared is in fact equal to f of 2. So yes, 0 does equal 0, so this does in fact work out. So in other words, basically by showing these 3-step criteria, you would include 2 into that interval. Now going and looking at negative 2, it's pretty much the exact same setup, just with negative 2. So our first criteria, f of negative 2, does in fact come out to be 0. Is that a real number? Yes, it does exist. 2. Second criteria, the limit as x approaches negative 2. Now we notice, looking at the graph, we are approaching negative 2 from just the right side. We don't have a left side to go off of our function, the square root of 4 minus x squared. And that limit does end up coming out to be 0 as well. We can see that it approaches that limit of 0. And then finally, step 3, or criteria 3. Do these in fact match? Well, the limit as x approaches 2 from the right side of our function 4 minus x squared is in fact equal to f of negative 2. Oops, this should have been negative 2 over here. And so, yes, they did end up matching. So we ended up with 0 is in fact equal to 0. Yep, criteria 3 is met. And as a result of that, we would then include -2 as well. So where is this thing continuous? Well, because we tested the endpoints, they did work and satisfy all 3 criteria for both of them. We would be starting out at -2 and going until +2. Keep in mind with interval notation, if it is including that value, we have that bracket around them. All right, and that's what distinguishes it from the parentheses where you cannot include them. But again, though, when you're looking at like limits as they're approaching a value, as long as they are equaling that f of a value, like we saw here, it does include those endpoints then. That's okay, that can happen. But again, though, that is example 3 from our 1.4 number 2 set of notes.